Hey everyone, Mr. Newman here, and today we're going to learn about piecewise and absolute value functions and how to write piecewise functions based on the absolute value function. So if you look here, we're given an absolute value function. We're asked to write a table, fill out the table, and then graph it, and then write a piecewise function. So first thing I'm going to do is I'm going to make my list of numbers. -2 to +2 is the simplest to write, and the absolute value of -2 is +2, and because the absolute value, remember, just means the distance from 0, but the fast way to think about that is just make negative numbers positive and keep positive numbers positive. So we do that, we get this list of numbers, and I'm going to plot these points and go ahead and plot all the points, and then I'm going to connect the dots, and I'm going to draw arrows at the end because the absolute value function keeps on going forever. Great, well that's the graph of the absolute value function, but can you see how it is sort of like two functions? There's one on the left and one on the right, or two lines. I'm going to divide it here with a green dashed line to show the two sides. And what we want to do is we want to write a piecewise function, meaning the function that says, oh, if x is to the left of the green dashed line, it's one thing, and if it's on the right, it's another thing. So we always start off piecewise functions by writing f of x equals, and then these curly brackets to show that all of this is in the piecewise function. The other thing we need to do is separate the two sides. So you notice the dashed line goes through 0. So I'm going to write one side as if x is greater than or equal to 0, and the other side is if x is less than 0. Next, we need to write the equations, and this is the most difficult part, so you need to listen carefully. We need to know the equation of a line. Well, y equals mx plus b is the equation for a generic line. What are m and b? Well, m is the slope, and b is the y-intercept. And the one other thing you want to know about slope is, one way to think of it is rise over run. That's the nicest way and quickest way to look at a graph and figure out the slope. So we're going to do that right here. Let's do that on the right here. You see how if I pick any point and go to any other point, and it doesn't matter which point you pick, I just pick two that are next to each other. To go from one point on the line to another point, to go from 1, 1 to 2, 2, for example, go up 1 and then right 1. That means the slope is rise over run, 1 over 1, or just 1. The y-intercept is where the line hits the y-axis, and that is 0. Can you see that right here? That's where it hits the y-axis. So our equation is, when we plug in 1 for m and 0 for b, is y equals 1x plus 0. Or in other words, just y equals x. Now that's our equation, but you notice on piecewise functions, you don't have to write an equals symbol because the f of x is already to the left over there. So I'm just going to put the right side. In other words, I'm just going to write x right there on the top. It's x if x is greater than or equal to 0. Now, on the left side, in order to find slope, we just picked any 2 points. I just picked -4, 4 and -3, 3, going from -4, 4 to -3, 3, but this will work with any 2 points. We go down 1, then we go right 1. So the slope, the rise over run, is -1 divided by 1. In other words, -1. The y-intercept is the same because it intersects the y-axis at 0, 0. So the y-intercept is 0. And if you plug in -1 for m and 0 for b, you get y equals -1x plus 0. So in other words, -x. That is how you write a piecewise function for the absolute value function. Let's try the next one together. I'm going to make a list of points, same list of points. Notice I'm leaving a little space because I've thought about this problem ahead of time, and I'll show you why in a moment. But go ahead and make that list and leave that space up there. So we plug in or substitute -2 in for x and see what we get. We put it into the function and we get out 0 because -2 plus 2 is 0, and the absolute value of 0 is 0. You do that for the rest of these and you get these points right here. And I'm going to draw those points. But wait a second. That looks like just a straight line. I know for a fact that absolute value functions are supposed to look like this v up here. What's going on? Well, with the v, we know that that +2 moved it left 2. So I need to try one more point over here to the left to see when it goes back up. So let's plug in -3 and see what happens. Well, -3 plus 2 is -1. The absolute value of -1 is +1. There's my point that goes back up, and now I can draw the v. If you see an absolute value symbol, never just draw a straight line. You know it always goes back up. So, now that we have our function, let's write the piecewise function. Now that we have the graph, let's write the piecewise function. So, for this, we have a dashed line. This -2 is where the function changes over from one function to the other function. And so, what I need to do is I need to write if x is greater than or equal to -2, and if x is less than -2. That's the dividing line. Now we're just going to use the equation for a line, y equals mx plus b, to find the slope and y-intercept. Well, the slope here, rise over run, we go up 1 and right 1, so it's 1 over 1, in other words, 1. And the y-intercept, can you see it there? That's right at 2. So our equation is y equals 1x plus 2. In other words, x plus 2. For the left side, it gets a little trickier. I'm going to do this in a different color so you see which function goes where. The slope, the rise over run, is down 1, right 1. So it's, again, -1 over 1, which is equal to -1. But the y-intercept is harder to see. Notice how the line doesn't actually intersect the y-axis. So we have to pretend, well, what if it kept going? Where would it hit? Can you see it? I'm going to just use a very light dashed line to show you where it would keep going. And you can use a ruler to figure these kinds of things out. It actually would intersect at -2. So our y-intercept, even though it doesn't actually intersect there, the y-intercept of the line is -2. That makes our equation -1x minus 2. So I'm going to write -1x minus 2, or you can write -x minus 2. Thank you very much for watching.